Hi Year 12. So this video is having a look at section 2 of your HSC trial paper from 2023. It was worth 90 marks, this section, and the next two sections are worth 90 marks. So let's have a look through the first part here. Question 11. For what values of x on the interval, and this is an important part because we only want our answers to be between 0 and pi on 2, does the line y equals 1 intersect the graph of y equals 2 sine of 3x? And that was worth 2 marks. So where they intersect is where they're equal. So where they intersect is where 2 sine of 3x is equal to 1. Okay, so that's a simultaneous equation, and the word intersect is the one that you're looking for there. So where does 2 sine 3x equal to 1? Well, there's a 2 in the front of there, so let's get rid of that. So where does sine 3x equal 1/2? Okay, so what we have up here is our interval that we're looking at is for x, and x is between 0 and pi on 4. If you're not happy with pi on 4, that's 45 degrees, so we're in that first quadrant. But because we have 3x, we might have to go around that unit circle that we're looking at more than once. Possibly not in this case because we are only restricted to pi on 4, but if we were between 0 and 2 pi, we'd have to be very careful or extra careful with our answers. So I'm just going to have a look at this and think of it as, well, what if it was sine theta equals 1/2? We can all do that, can't we? That's fairly simple. So all we're doing there is saying, well, if that was theta, what's inverse sine of 1/2? And that's going to be 30 degrees, or we want to do it not in degrees, we want to do it in radians, which is pi on 6. If you don't know how to change your 30 degrees to radians, what you need to do is, you've got 30 degrees, you're going to times that by pi on 180. The pi stays there, and the 30 over the 180 cancels down to 6. So you've got pi on 6. And the reason that you're showing it in radians is you've got radians there as your domain. So we want to spit out that as our answer as well. Now, that's not the only place where we have an answer. Okay, so we're going to think back to all statements to central. Because we've got sine of theta being 1/2 and 1/2 as positive, we're looking for the positive quadrants of sine, which are the first two. So we have that 30 degrees, which we've changed to pi on 6. But we also have 180 take away 30 degrees, which is 150 degrees. If we change that to radians, what we'll have there is, that'll break down to 5 pi on 6. So far we've got pi on 6 and 5 pi on 6. But that was for just theta. And because we're going and looking at 3 theta or 3x, we will need to bump those angles we've got up here by another 2 pi. I'm basically going to add another 2 pi. I'm going to go back around my circle again, or basically going around that unit circle another whole time. So what we're going to end up with is 13 pi on 6, and 17 pi on 6. Now that was for theta, or you can call it x, but I've just basically over here let theta be equal to 3x. So I need to go back here and let that theta be equal to 3x. And now I need to divide each of these things I've got up here, each of my solutions, by 3. So pi will become 6 times 3 on the bottom, which is going to be 18. I'm going to have 5 pi on 18, 13 pi on 18, and 17 pi on 18. Now, they would be the answers if our domain was between 0 and 2 pi. We'd be looking at some of those answers. But because I only want my answer to be in the interval between 0 and pi over 4, my only answer that I am going to have is going to be that x is pi over 18. And that shouldn't have a 3 there, sorry. Okay. So I'll pop that 3x up there. That looks a bit better. Okay, so that's my answer. Pi over 18. That was worth 2 marks. And overall, that was not done well. The first thing that people seem to not be able to do was divide by the 2 and get 1/2. And then the other thing, people didn't know what to do with that 3x. So that would be a really good one to practice. Okay, let's have a look at the next one. 12. Each one of these was worth 1 mark. I'll try and go a little bit faster. Given that f of x is x squared minus x and h of x is 2x plus 1, we want to find f of minus 2. So f of minus 2 means we're going to pop minus 2 where there was an x in there. So that's going to be minus 2 squared. If you made a mistake, that is where you made the mistake, because you need to put the minus in the brackets and square the whole thing. And then it was minus, and we're minusing a 2 again. So when I square minus 2, I get 4, and I'm going to be going minus minus 2, which is a plus 2, and my answer is 6. People who made mistakes in here, I think, were just silly mistakes, but to get your 1 mark, you needed to get that answer entirely correct. The second one. Now, I was surprised because I thought you guys at this point would be quite good at this, but this question was actually done really badly. We have got f out the front, and inside that f, we have h of x. So if we look up here where we had an x, wherever there was an x in this function, I'm going to put in h of x. And h of x happens to be 2x plus 1. So where I had an x squared, I'm going to have a 2x plus 1 squared. Take away, and this is the other mistake, x. My x is h of x, I'm going to take away 2x plus 1. But what most of you, or a lot of you, didn't do, again, it's just a silly mistake, you're taking away the whole of 2x plus 1. So that minus is going to be applied to each of those terms in there. You cannot leave that as an answer, okay? It doesn't say to simplify, but you're in advanced maths now and you always need to simplify. Let's open up this first bracket. So square the first term, 2 times the first times the second, square the last term, and then apply that minus to the second bracket. So we end up with minus 2x minus 1, and now we neaten that up. We're going to have 4x squared, we're going to have plus 2x, and the 1s are going to cancel each other out. So you could have left it like this, or even better, taken out a 2x, and you would have had 2x plus 1. This next part was done quite well. Find x where h of x is equal to 0. Well, if we let h of x equal to 0, that's 2x plus 1 is 0, and we just need to solve for x in that case. So 2x is minus 1, and x is minus 1/2 to get your mark. Okay, again, this question was done quite poorly, and I think this is another one. You need to know how to do these. These are bog stock standard questions. Find the equation of the normal, okay? So you're finding an equation, and it's not of a tangent, it's of a normal. What is a normal? A normal is a line that is perpendicular to the tangent. So you need to look at the gradient. And it's going to be the normal to this curve here at a point x equals 1. That was the other thing people did wrong, is they didn't substitute in the x equals 1. And then the other thing you needed to do to get your full marks is it says to express your answer in general form. So you needed to have everything onto one side and have it equal to 0. So let's have a look what we need to do. So equation of the normal. To find the equation of the normal, we need to deal with the tangent first. And then once we've dealt with the tangent, we can look at the normal. So how do we find the gradient of the tangent? That is m, that is dy dx, or y dash. How do we find y dash? Let's differentiate our y up here using the chain rule. The 4 comes down and times by the 2 to get our 8. We have 5x minus 4, and we have a power of 3, and we times by the derivative inside that bracket, which is 5. So that simplifies to 8 times 5 is 40. 40 times 5x minus 4 to the power of 3. Now that is your general gradient of the tangent at any point, but we want it at the point x equals 1. So at x equals 1, we're going to sub that x back into here, okay, to find out what the gradient is at x equals 1. And that will be 40 lots of 5 times 1, which is 5, minus 4 to the power of 3, which is going to be 40. So 40 is our gradient of the tangent at x equals 1. We want to find the gradient of the normal. So we know that the gradient of the normal times the gradient of the tangent is equal to minus 1. So if I've got my gradient being 40, then my second gradient that I want is minus 1 over 40. And that's my gradient of the normal. Okay, that's at x equals 1. Okay, I need a point for y as well, because what I need to do is find the equation. So that's what now that we've got our gradient, we can find the equation. And our equation formula is this one, okay? And we've got our m, we've got an x value. I need to find that y value. The y value is the one that matches our x value. So what's the value of y when we've got x? Y is going to be 2 times 5 times 1, which is 5 minus 4 to the power of 4, which is going to be 2. Let's pop that in the equation. So y minus 2 is equal to minus 1/40th x minus 1. Now, yep, that's an answer, but that's not the answer they want, because if we look back at what the question said, the question wanted it in general form. And that general form is our ax plus by plus c is equal to 0. So I need to multiply everything by 40. So what that will become will be 40y minus 80 is equal to, and that minus 1 is still there, and it's going to multiply out by both of them, minus x minus 1. So that 40 is being multiplied by each of those terms. When I multiply the right-hand side, it cancels out on the bottom. So what you're going to end up with when you take that over into the general form, what you're going to end up with is 40y plus x, and you'll have minus 80, and that will become, I've made a mistake there, haven't I? Plus 1 on that side. So when it goes to the other side, it's going to be minus 81, and that is equal to 0, and that is the answer. Okay, so in that question, you would have got 3 marks for the correct answer that I just showed you. 2 marks if you find the gradient of the normal, that's what I was looking for, and 1 mark if you find the derivative, and that's our marking schedule for that. Okay, question 14. An investment is modelled by the recurrence relation V of n plus 1 is equal to V of n times 1 plus r plus d. And it's given you what all those bits of information are, where V of n is the value of the investment after n plus 1 payments, and then V of n is after n payments. So V of n plus 1 is one lot of value after the V of n, and that is found by multiplying that V of n times 1 plus r, and that's the rate of interest, and D is the payment per compounding period. So our rate of interest here is 4%. He makes an initial deposit of $1,200, George does, and it's compounding annually. And he's having an additional deposit of $150 every year. How many years will it take for George's investment to accumulate to 1,818? So how many years is going to be n? That's what we want to find. Let's see what we can do. Okay, so V of 1. I'm going to pop that into the equation up here. So after 1 year, George is going to have the initial deposit, which was the value of the investment after n payments. So that's going to be the initial deposit of $1,200 multiplied by 1 plus 0.04. So that was our interest rate. We've changed that to the decimal. And we're going to add on to that our additional deposit, which is our payment of $150. Okay, which is $1,398. V2 is going to be now our $1,398, and we're going to apply that same amount in our equation plus $150, which equals $1,603.92. So what you can see I'm doing is saying, well, how long does it take for George's investment to accumulate to 1,818? Well, I'm not there yet, so let's have a look at what V3 is going to be. If I pop V3 in, I get 1,818 and I think it was 76 from memory, like that. So I basically reached that value, so it's going to take 3 years. People did not do this one very well, I think, because it was just slightly different to maybe what we've looked at in class. You didn't need anything fancy, but just working through each of those gave you your results for that question. Next question. We're evaluating the integral between 0 and minus 3 of the square root of 3x plus 9 with respect to x. Now, again, not very well done. What we needed to do was to rewrite our function with a fractional indice because you can't do it any other way. And what people needed to remember to do was look at your formula sheet because it's pretty much on there. But when we are integrating, the rule is we add 1 to the index, okay? So I've still got 3x plus 9. Add 1 to the index. A half plus 1 is 1.5 or 3 over 2. Divide by that 3 over 2. And divide by the derivative inside. So I'm going to put that out the front. And the derivative inside is 3. People generally did not do that or did not know what to do with the bottom line. What I could have done, I'm going to leave that third out the front from dividing by it. When I added my power and went from -1/2 to 3 on 2 and divided by the 3 over 2, what I'm basically doing is multiplying by its inverse. Like that. And so what I end up in my square brackets are basically 2/9. And very few people actually got to that. So that shows me that you don't actually know what your rules are for integrating. Okay, the next step that you needed to do was pop 0 in to your function and then take away what you got when you popped -3 in, and you would have gotten 6 as your answer. Okay, question 16. Now, this was worth 2 marks, and it says solve the equation 2 log of x plus 2 minus log of x is equal to log of 2x plus 1, where x is greater than 0 for x. Now, out of all the questions that I marked in this section, this one was the question that was done the worst, definitely, by everybody. I think in the whole of our year, we only got, 2 people that actually got this out. So you need to know your log laws, and that is all this question is about, is getting your log laws sorted and getting everything into a workable format. We can't have that 2 out the front, and then we've got to think about what our log laws are, okay? So I'm going to remove that 2 from the front first because it's not nice out the front, and it comes back up the top and I square it. Because remember, there's a log law that says if there's a power, I can bring that down the front. So I can reverse that rule as well. So that's what I've got to start with. Okay, there's a log law that tells us that we can do something when we take away one log from another, and that's divide. So I can have log of x plus 2 all squared divided by x is equal to log of 2x plus 1. Okay, so you should have then expanded the top line up here, and you would have gotten the x squared plus 4x plus 4. X is on the bottom, and that's equal to log of 2x plus 1. Now, there's 2 ways you could have done this question then, an easy way or a hard way. You've got a log on both sides, and there's nothing out the front of the log. You can cancel the logs out. They're basically, it's a rule that you can do, and I don't know how many of you actually have done that before. X squared plus 4x, plus 4 then, over x is equal to 2x plus 1. If I cross multiply by my x, I end up with x squared plus 4x plus 4 is equal to 2x squared plus x. And then I need to get everything over to the one side. I'm just going to pull everything over to the right-hand side. I'm going to end up with a 0 on the left. I'm going to end up with x squared minus 3x minus 4 equals to 0. And I can factorize that. I might do that up here. We're going to have, I get x plus 1, x minus 4. Setting each bracket to 0, I get x is minus 1 and x is 4. However, the question says where x is greater than 0. So I need to have x equals 4 as my solution. Now, there's another way to work this one out. I might give that to your teachers to have a play around with, but basically what you're going to be doing, the other way would be using your log laws to get the logs over to the left and then divide. But it does get a little bit messier, but maybe that's the only way that you do see it. So there is that other option as well. Okay, but overall, that was done really not well. I was looking at, for 2 marks, you had to get the right answer, okay? And for 1 mark, I needed you to get some form of a quadratic into the question, which was, again, needing you to use your log laws to do that. So if you want to go and practice that for your HSC, those kind of questions are important because they might be the 2 marks that get you a mark that someone else doesn't get.